Imagine that you are the manager of a dream team made up of real professional athletes. That's basically what fantasy sports is all about. I've got here two screenshots from a real fantasy sports competition that is happening this weekend. And here's how it works. DraftKings will give you a budget of $50,000 in play money. With that budget, you need to select 9 players to make up your team. Each player has a salary based on how good they are or how likely they are expected to perform well. So the better the player, the more they cost. And what your job is to do is to balance your budget. You can't just fill your lineup with all of the superstars because you'll run out of money. Instead, you need to find a mix, some highly priced stars and some lower priced players who you think will perform above the expectation. Once the games begin on Sunday, your fantasy team will earn points based on how your players will perform in real life. So, for example, if you're playing fantasy football, like the examples in this screenshot, touchdowns, passing yards, and tackles can all add to your score. At the end, the team with the highest score wins. In this particular example, it costs $3 to enter, and there are $800,000 in prizes that are available. So, in short, you get to pick, or you get $50,000 of salary. You pick 9 players. 9 players have to form part of specific positions, so 1 QB, 2 RB, 3 WR, and so on. And their real life performance equates to your fantasy points. If this is all brand new and feels a little fuzzy, don't worry. If you search on Google for the term fantasy sports, you will find full, wholesome explanations with examples to help make it click. But for now, what I'd like to do is to use Excel's solver that can optimize our 9 player selection given the constraints related to salary and positions. Now, on the DraftKings platform, there is this export salary list to CSV option, which I clicked on and have imported here as part of this spreadsheet. So we're going to use this spreadsheet to construct a model in Solver that will help us optimize the model. Now, to help me out here, I'm actually just going to copy and paste this first screenshot here, over here. The reason I'm going to do that is because this screenshot contains the 9 players that I need. I need to have 9 players spread across these positions. So what I'm going to do here is type position, and I'll just retype this table that is given here directly in my spreadsheet up here so that it is workable for me. Oops. And the flex is RB, WR, or TE. I'm actually separating flex for a specific reason. I know flex is second from the bottom here, and for me, I'm kind of separating it from the rest for a reason that will become apparent hopefully quite soon. Flex could be RB, WR, or tight end. Oh, and I shouldn't have deleted it quite yet because I need the quantity I need of each of those positions. Bear with me. I'm getting ahead of myself. So I have positions, and I need 1 QB, 2 RB, 3 WR, 1 TE, 1 flex, and 1 DST, and 1 flex. Okay. Now the flex position is RB, WR, or tight end. So we have like 2 RBs, 3 WR, 1 tight end, but for one of those 3 positions, we actually get to select one more. So it's like I could select 3 RB, 3 WR, 1 tight end, 2 RB, 4 WR, 1 tight end, 2 RB, 3 WR, or 2 tight ends. I got one additional position across the 3 of those. So there we go. So the position is given here. Now to start with this, I actually don't really care if I don't need this like flex here. So I'm going to get rid of that, and I could get rid of that a couple of ways. I'm going to get rid of it by copying and pasting. One way to get rid of it would be to using this text to columns feature here, and I'm going to search by delimiter. My delimiter is a /. And if I do a / here, what it will do is look for a / and split one column into 2 columns based on that character. So I could click on finish and then just like delete delete this column here. Another way of going about this would be like I've copied this column and I pasted it here. I could select this entire column. Oops. I could select this entire column and hit Control H, and I could say like /flex, find /flex, and replace it with nothing. And if I do that, it'll just delete it for me. So maybe I'll do that this time. I'll call this position, and this is a column that I am adding to the data. I like to maintain the integrity of the data, how it comes to me whenever I download things from the internet. I don't like to touch it, modify it, or do anything at all to it. But this is a column I'm adding, so I just like to differentiate what I've done to how the data came to me by just coloring the columns a little bit differently. So I've got this like position column now, and that's going to be useful for us in just a few moments. What I'm going to do next to this position column is add a new column called select. And this is going to be a binary column consisting of either ones or zeros based on whether I want a player to form part of my team. For example, Jonathan Taylor in row 2, if I want them to be on my team, I'm going to say 1. If I don't want them on my team, I'm going to say 0. So I'm going to constrain this column to be one of two possible values, a 0 or a 1. What that will allow us to do is to calculate the salary used in constructing this team. The way that we can do that is just by multiplying the salary by this binary column, which is going to consist of a 0 or a 1. So if I zippity-doo-dah this salary down to the extent of the data, and I have a few ones in here, these ones represent salary or players that are forming part of my team. So my team is now costing the combined value of those three players, 23,000. So what I want to do is have a total for these two columns, 23,000 and the number of players that I have selected. Now, if we remember, I think I needed 9 players and my budget was 50,000. I'm actually just going to double check that. I don't remember if it was 50 or 55. Hold on. 50. So there we go. So right now I have 3 players selected. Those 3 players cost 23,000. I'll also calculate while I'm down here what my remaining budget is. I'm given a budget of 50,000. Right now I've consumed 23,000. So there's 20,000 that remain. But I don't want to like select these 9 players myself. In fact, I want Excel to select them for me. So like these are going to be my variable cells that Excel will just do it for me. So it's okay that they're blank right now. But while we're here, let's summarize, let's do a calculation that will calculate how many QBs are being drafted to our team. So I'll say selected maybe. And to do this, I'm going to do a sum if. My range here is this position. I'm going to filter the position for, in this specific cell, quarterback. And then I want to sum together the select column. And I should get zeros everywhere right now because I don't have any ones. But if I type, just for illustration here, if I type 10 for this RB, I'll have this 10 show up for RB now. If I put 1 next to RB, as soon as I press enter, this 10 will move to an 11. And if I put another 1 next to this RB, this 11 will move to a 12. So I'm just here, have a calculation that is calculating the total number of players that I have selected or drafted to my team. I know I can't select 10 of the same player. I can only select a 1 or a 0. I was just doing that to illustrate the sum if function. Now in drafting this team, I want, presumably, hopefully we all recognize, you want the highest possible points that your team is going to produce. And we're given this average. So we're going to use this average to calculate an expected points. Here it's going to be, again, the select column multiplied by the average. And I'll copy and paste this down. And and add my sum function next to it. So this is basically the entire setup that we need in order to move forward in Solver. Recognizing I want my objective to be the maximum possible expected points. So let's go into Solver. All right, just resetting my Solver model to make sure it's blank. So hopefully, again, we're recognizing I want to construct a team that produces the maximum possible expected points. And I've calculated my expected points to be here in this cell here. So K201. This is my maximum possible expected points. By changing which players form part of my team, which is column I. So I'll just select here. If I were to click on solve right now, Solver will not be able to find a solution. The reason is because it would push each value, each cell in my changing variable cells to infinity, which would make my expected points calculation be infinity times their average points per game, which would push it to infinity. But I can't choose an infinity number of players. In fact, I can only choose each player one time. I want column I to be a binary column consisting of either ones or zeros. So that's my first constraint that I'll add. I'll go through column I. Select the values in column I. And I'm going to say the values in this column have to be binary values, meaning they're only zeros or they're ones. So I've added in one constraint. If I click solve now, Solver will find a solution. So I'll do this and demonstrate. Presumably, it's just going to turn on a 1 for every player. I want every player to form part of my team because that produces the maximum possible expected points. But I've drafted now 199 players. I only need 9, and it cost me 884,000. I went over budget by 834. So I actually need to add more constraints to this model. Let's start first with the number of players that we need. I only need 9 players. So I'm going to say the total number of players I select must be equal to 9. If I click OK now in Solve, it will select the 9 players that maximize my expected points. However, I didn't constrain it by budget, so I'm expecting here when I do this, it will exceed my budget restriction. And that's exactly what it's done. I have my expected points here. I do have 9 players, but I went over budget by $9,800. So maybe I add in another constraint. I'm just going to go through these one at a time. I'm going to say my remaining budget here is going to be greater than or equal to 0. Okay. Let's see what happens when I solve this now. I've drafted 9 players. I have $100 remaining. This is my expected points. But let's scroll up to examine what's going on. And then the ones here are the actual players that would form part of my team. My optimal lineup has selected 5 quarterbacks, but I'm only allowed to select 1 quarterback. So this is a little bit of a problem. So I need to constrain my model even further. I need to add a constraint. My constraint is that my QB selected here, the sum if, it must be equal to 1. And I click OK. And I'll click solve. I found a solution. Let's go look at it. I have 9 players selected. I needed 9. My budget is $49,900. I have $100 remaining in my budget. This is my expected points this lineup will produce. And it looks like I've actually satisfied all of my position requirements. I needed 1 QB. My model selected 1. It's this. I guess I don't see it right now, but you know what? We could find it really quickly. Data filter. I'm going to filter for only the ones. These are the 9 players here. So this QB, Marcus Maroida. Okay. I needed 2 RBs. I selected 2. I needed 3 wide receivers. My model is selecting 4, but I was also allowed 1 flex position, which is another roster position that could be either RB, WE, or tight end. So this 4 is actually okay as long as both RB and TE, the selected equals the need. And in this case, it does. So this is the optimal lineup. So to look at the optimal lineup, all I would do is filter for the ones, and I would go to DraftKings and draft this. Now, as a disclaimer here, this is not an endorsement to do this. This would not be good enough to compete with experienced players. Why? Because, well, a few reasons. One, this is the easy part. This is what pros do. But the hard part is getting accurate values for these inputs here. Players never really perform to their average. They perform according to the matchup. So you need to actually have more accurate values as inputs to have an output that is meaningful, meaning that this expected points output, because it relies on these averages, is not really all that great. But this is a methodology that you could use if you did have good inputs into the model. This would produce the optimal lineup for you. However, just as to illustrate here, this optimal lineup, 172.38 points, it wouldn't really materially shift if we were to delete one of these players. Because I'm sure like the next best lineup is probably like 172.2 or something like that. I won't do it in this video, but I'm sure that the next best lineup is pretty close, which means that like it really shows that the values you have on your inputs are what are more important factor in driving successful outcomes in a game like this. But anyway, there you have it, using Solver to optimize a fantasy sports lineup. Thank you, everybody. Take care.